Good morning, children. Welcome to all of you in the new session of physics gravitation chapter. Today, I will explain the Newton's third law of motion and gravitation relation. Okay. As all of you know, what is the Newton's third law? Newton's third law is action reaction law, where the statement is every action has been equal and opposite reaction. Okay. So what will happen here? Newton's third law of motion also holds good for the force of gravitation. That is here. This motion that when Earth exerts a force of attraction on an object, then the object also exerts an equal force on the Earth. Moving forward in the opposite direction. Thus, even falling object attract the Earth towards itself. When an object, say a stone, is dropped from a height, it gets accelerated and falls towards the Earth, and we say that the stone comes down due to the gravitational force of attraction exerted by the Earth. Now, if the stone also exerts an equal and opposite force on the Earth, then why don't we see then why don't we see the Earth rising up towards the stone? What is the reason here? Reason is that because the Earth mass is very much than that of the stone mass, and acceleration produced by this force for stone is very much high in comparison to the Earth. As in the picture also show, acceleration is inversely proportional to the mass. A is equal to F upon m. Then we look here, A is inversely proportional to the m. When m is very high, then A is very low. If m is very low, then A is very high. Okay. It is clear from this formula that the acceleration produced in the body is inversely proportional to the mass of the body. Now the mass of a stone is very small, due to which the gravitational force produced a large acceleration in it. Okay. Now moving forward. Now we will talk about the free fall. What is free fall here? The falling of a body from a height toward the earth under the gravitational force of earth with no other forces acting on it is called free fall, and such a body is called free falling body. If any doubt, then I again repeat it. The falling of a body from a height toward the earth under the gravitational force of earth with no other forces acting on it is called free fall, and such a body is called freely falling body or object. Now moving forward, gravity and acceleration due to gravity, what that is represented by small letter of g, it is totally different from capital G. We have already studied that the gravitation is the force of attraction acting between any two bodies. If one of the bodies is earth, then the gravitation is called gravity. That is, gravity is the force by which earth attracts a body towards its center. When a body falls from some height, the velocity of falling object continuously increases. Okay children, we can say that the uniform acceleration produced in a freely falling body due to the gravitational pull of the earth is known as acceleration due to gravity. That is given here in these two lines. It is denoted by the letter small g. That is very important for you. This is small g. It does not depend upon the shape, size, etc. of the body. Suppose a body of mass small m be situated at the surface of the earth or at the small height above the surface. Let mass of the earth is capital M and radius r. Then, according to the law of gravitation, the force of attraction acting on the body due to the earth is F is equal to g/m/r square. Suppose the picture is look like that. This is earth, suppose this is E, and the small mass is kept near the surface of the earth. Then this is the radius of earth, that is r. So relation is given here, F is equal to g/m/r square. Then acceleration A is equal to F upon m. Acceleration A is F upon m. Substituting the value of F from equation number 1, F की वैल्यू पुट की गई. Acceleration is equal to g/m/r square by m, that is gm by r square. This acceleration produced in the body by the gravitational pull of the earth is called acceleration due to gravity, that is g is equal to gm/r square. The value which are given here, capital G 6.67 10 to power minus 11 Newton meter square per kg square. Mass of the earth is 6 into 10 to power 24 kilogram. Radius of the earth is 6.4 into 10 to power 6 meter. After putting this in this value, after putting all these value in this formula, that is small g is equal to gm/r square, then we get the value 9.8 meter upon second square. This means that the value of g does not depend upon the mass of the body. Now moving forward, variation in the value of g. Value of g close to the surface of earth is 9.8 meter per second square. It is not a universal constant. Second is variation on the surface of the earth. The earth is not perfectly spherical in shape or size because it is a oblate sphere. Its equatorial radius is about 21 kilometer more than polar radius. So at the surface of earth, g is minimum at equator and maximum at poles. Second point is variation with altitude. With increase a height, value of g decreases on going below sea level. Also, such as in deep mines, the value of g decreases. At the center of earth, the value of g is 0. This is important. The difference between capital G and small g, which are given here in the 4 points. First is, it is a force of attraction between two bodies kept 1 meter apart. It is accelerated produced in the body due to attraction force of earth. Gravitational constant g is a universal constant. Second point, its value changes from place to place on earth, means small g. The unit of capital G is Newton meter square per kilogram square. However, the unit of small g is meter per second square. Fourth point, it does not depend on the quantity. That is, g does not depend upon the quantity. Small g depends on mass and radius of the earth. That is earlier formula, g is equal to gm/r square. Now moving forward, and we will talk here mass and weight. What is mass? The amount of matter contained in a body is called its mass. Mass is a fundamental property of matter. Okay. The mass of an object is constant and does not change from place to place. The SI unit of mass is kilogram. This. Now moving forward, weight. What is weight? Weight is nothing but it is a force. The force with which a body is attracted towards earth is called its weight. The earth attracts every object with a certain force, and their force depends on the mass of the objects and the acceleration due to the gravity. That is, the value of mass, that is force, is equal to F is equal to ma, or F is equal to mg. That is also denoted by W. It means you can also write here W is equal to mg. That is weight. What is W here? W is weight, m is mass, and g is gravitational acceleration. So the unit becomes weight is Newton because it is a force. Now we can find the differences between mass and weight. There are four differences which are given here. First is mass. For mass, the amount of matter contained in a body is called its mass. However, weight, the force with which a body is attracted towards earth is called its weight. Second point, mass of body is a constant quantity. However, weight of the body changes from place to place. Okay, on the surface of earth on account of change in the value of g. Third point is mass is a fundamental quantity. However, weight is derived quantity. Unit of mass is kilogram and unit of weight is Newton. This is very important for you.